Assalamualaikum and hello everyone. In this video, we will discuss transition metal complex in daily life. First, let's look at the objective of this presentation. The first objective is to describe the characteristic of transition metal complex, such as their ability to form complex ion and act as a catalyst. Next, to explain the uniqueness of transition metals compared to other elements. For example, many transition metals can have different oxidation states, which is not common in other elements. The third objective is to identify their uses in daily life, such as in electronic, construction, and automobile. Last but not least, to discuss their application in medicine and cosmetic, like in cancer treatment and sunscreen. Now let's move on to the introduction. Transition metals are elements in group 3 to 12 of the periodic tables. They have valence electron in 2 shells, which give them special properties such as forming complex ion, showing variable oxidation states, and being widely used in daily life. Because of these properties, transition metal complex play an important role in our everyday lives, including automobile catalytic converters, electronic, construction, medicine, and cosmetic. They are very important for modern technology and healthcare. The specific example and explanation will be explained by my other group member.
Transition metals have several important characteristics. First, they have variable oxidation state, which allows them to form many different compounds. They are also good catalysts, meaning they help reaction occur faster without being used up. In addition, many transition metal compounds are colored due to electron transition in the d orbitals. Transition metals can also form complex ion when they combine with the ligands. Most transition metals have a high melting points and high density, make them strong and durable materials. Lastly, they have a partial filled d orbital, which contribute to their unique properties.
Next, we're going to move on to the uniqueness of the transition metal. The first uniqueness of transition metal is as catalytic properties. Many transition metals are used directly as catalysts in industrial chemical processes and in the anti-pollution catalytic converter in car exhaust. The first one is ion catalysts are used in the Haber process for the synthesis of ammonia. Nitrogen will react with hydrogen and synthesize ammonia with the help of ion as catalyst to make sure the Haber process be more efficient. And secondly, manganese dioxide, which is a black powder, readily decomposes aqueous solution of hydrogen peroxide, so that hydrogen peroxide can be synthesized to hydrogen and oxygen. The second uniqueness of the transition metal is variable oxidation states, which means one transition metal can form ions with different charges. It is because loss of electron. Transition metal form oxidation state which is tied with +2 by losing their 4s electron first, followed by 3d electron. Although 4s electrons are filled before 3d, but the 3d electrons are closer to the nucleus, so the outer 4s electrons are higher in energy and remove first rather than d electrons. Because of the 5d orbitals, it allows various oxidation states because d electrons are easy to remove, and half-filled d orbitals are more stable due to their symmetrical arrangement. If we look at this table, across the group left to right from scandium to manganese, it will increase because of the loss of all the electrons in both the s and d orbitals of their valence shells. And then from manganese to zinc, it will decrease because of the pairing of d electron occurs after manganese. Lastly, transition metal also is a colored compound. Transition metals form colored compounds and complexes. Colors can vary depending on the charge on the metal ion and the number and type of group atoms, ligands attached to the metal ion. When ligands bond to a transition metal ion, the d orbitals split into different energy levels. So when d orbitals are not fully filled, the electrons can absorb light and move to a higher energy d orbital. The color observed depends on the energy gap between the d orbitals.
we move to the next part, which are the uses of transition metals in daily life. So, the transition metals play very important role in huge sectors such as automobile, electronic and technology, and also the infrastructure. So first, let us take a look about transition metals that act as automobile catalytic converter. As we all know, transportation exhaust emission can cause air pollution. By using platinum, the damaging exhaust emission will transform into much less toxic. How does this work? Based on its catalytic properties, the direct use of platinum is very excellent in speeding up redox reactions without being consumed. So, the example is stated as below, which is carbon monoxide can turn into carbon dioxide, iron hydrocarbons will turn into carbon dioxide, and also water. Other than that, platinum, which are transition metals, has physical properties which is high melting point. So, that will make it does not decompose or evaporate easily under harsh engine conditions. Next, we have transition metals in electronics and technology. Transition metals are considered as the most vital materials in this sector because of its great conductivity as well as their magnetic properties. As example, copper is greatest part of wiring and circuitry in CAN electronics, and also cobalt is also incorporated in making magnets supposed for many electronic products. Last, we take a look at this one of the most important sectors that need to be built strongly for safety reasons, which is construction and infrastructure. The highest quality of the materials used in this sector is the most important thing in strengthening the infrastructure. This is where the transition metals are involved. So, as example, thin wires of steel ribbed with transition metals such as manganese. Again, how does this work? First, manganese is added in steel in just small amounts to improve by increasing the strength and hardness. So, due to the hard, tough, and strong metallic atoms bonding in these transition metals, manganese will make steel less likely to crack even under the heavy loads. Other than that, steel reinforcement is often ribbed and not smooth. This will improve bonding between the steel and concrete so the steel will not slipping inside the concrete under stress condition. By this way, a better corrosion resistance and durability infrastructure can be built.
So next, let's go through to the application in medicine of transition metal. Firstly, applied in cancer treatment. Cisplatin is a platinum complex which is commonly used in treating tumors such as leukemia, testicular cancer, and ovarian cancer. So why we use platinum complex? Platinum is compatible with the human body, which determines the safety of uses both internally and externally due to the oxidation state. Due to its square planar structure, it can bind to DNA, forming cross-links that inhibit the DNA replication and prevent cancer cell division. Next is also applied in glucose metabolism. Vanadium sulfate, which is a simple salt containing vanadium in the +4 oxidation states, is commonly used as a nutritional supplement, especially among athletes. It is known for its role in enhancing glucose metabolism. So, why is vanadium used as a glucose metabolism enhancer? This is because vanadium compounds, particularly vanadate, possess insulin mimetic properties. Vanadate is able to inhibit specific enzymes known as protein tyrosine phosphatase (PTPs), which normally act to reduce or switch off insulin signaling.
By inhibiting protein tyrosine phosphate, vanadin helps prolong and enhance insulin signaling pathways. As a result, glucose uptake by muscle cells is increased, leading to improved energy availability and reduced blood glucose levels. Therefore, athletes take this supplement to enhance energy utilization by promoting greater glucose uptake and metabolism in muscle tissues. So now, let's discuss the application of transition metals in cosmetics. It's interesting, right? Firstly, sunscreen. Sunscreen commonly contain inorganic metal oxides such as titanium dioxide, zinc oxide, and aluminum oxide, which act as physical UV filter by reflecting and scattering UV radiations. Titanium dioxide mainly protects against UVB rays, while zinc oxide provides protection against UVA rays. Therefore, the combination of titanium dioxide and zinc oxide offer broad-spectrum UV protection. To improve cosmetic appearance, micro-sized particles are replaced with nanoparticles, making the sunscreen more transparent on the skin. However, due to the potential photocatalytic and toxicity effects, these nanoparticles are usually coated and strictly regulated to ensure safety. Next, application of transition metal as a color additive of cosmetics. Iron oxides are widely used as inorganic synthetic pigments in cosmetic products such as lipstick, eyeshadow, blushers, and also foundations. They function as color additive that provide stable and long-lasting colors in cosmetic formulations. The color produced by iron oxides depends on a specific type of iron oxide or the combination of different iron oxide used. As a result, a wide range of colors can be achieved, including yellow, red, orange, brown, and black. Iron oxides are naturally occurring minerals and are considered safe for cosmetic use. The amount of iron oxide used in cosmetic products is strictly regulated and monitored by the Food and Drug Administration (FDA) to ensure consumer safety and to minimize any potential risk to human health.
In conclusion, transition metal complex play an important role in the daily life. There are unique characteristics such as a variable oxidation state, the ability to form complex, and catalyst properties make them very useful. Because of this, transition metals are widely used in medicine, cosmetic, and other industries.